Okay, so I am going to talk about the scientific revolution as a change of worldviews. Um, I, I am a researcher here at the University of Helsinki, but much of this research was done in an earlier project in the University of Uppsala. And I'm just going to talk about worldviews, how to compare worldviews to dialectical and metatheoretical means, and also take the development of quantum mechanics and also the scientific revolutions as kind of examples. I don't really know that well, and I've used second order sources mainly, so there might be mistakes or confusions, but I am mainly trying to kind of use a model that I have developed for comparing worldviews. So you can define a worldview by kind of a kind of structure as a system of science, practices of interpretation, and a moral framework for capturing the most fundamental truths about a domain or system. So this is kind of doesn't really explain itself. I use Peirce's ideas of science and also ideas of knowledge through belief system from Johann Georg Hamann and Michael Polanyi as a background. But to take this kind of idea of system of science, for example, the kind of science that a worldview uses in its activities, and these science are networked in the practices of a worldview. You could also kind of alternatively describe worldviews as general conceptual schemes. Then there are these kind of practices of interpretations, activities of a worldview for responding to reality, to interpreting it. These kind of practices also include frameworks. And a framework includes an agents, this kind of not so much positions, but kind of distinctions within the framework, habits or practices, and goals for reaching. These frameworks also include goals, these kinds of acts or positions. I was just kind of thinking of positions in a game or actions within a kind of system of activity or things like that. And they kind of include signs to make distinctions. And moral frameworks involve normative questions about the good. They are frameworks, they have agents as moral agents, moral distinctions between right and wrong, good or bad, sound hypothesis, virtuous theories versus bad theories. Then also virtues, well, theory virtues are one case, and also goods that are aimed at, and there are this kind of hierarchy of goods in not necessarily in cognitive frameworks, but in worldviews in general. Hypergoods or the other goods, life goods constitute a good life, and also moral sources empower one to be good. For example, say the idea that being reasonable or rational empowers one to be good. And also metaphysical systems and religions are all examples of worldviews. We are talking about metaphysics here, but they offer starting points or meta theories for empirical practices. This kind of general conceptual schemes lead to paradigms, and also paradigms lead to theories and interpretations, and they form a kind of pragmatic circle modeled on Peirce's abduction, deduction, and induction. Abduction means formulating a hypothesis and best explanations. Deductions are deducing results, and then inductions means testing them, quite often statistically. But in worldviews, we have a circle of starting with forming a worldview, then using it to form interpretations and practices and so on, and then empirically testing, for example, having an mechanical worldview led to classical physics, which was then tested through scientific practices, for example. And these kind of general conceptual schemes and rules of language use. Language uses are these kind of practices for interpreting the science of a framework or worldview. They are interpreted, they include a kind of ontology or a basic worldview of a practice. The kind of concept, the existence there is interpreted via seeking and finding. Tuukka Tanninen had a presentation on Hintikka yesterday. He talked about this. Also, possible properties and re-identifications characterize objects. We can say that, for example, a particle has a mass or it has a velocity or so on. And you can re-identify it across time, for example. And these kind of ontologies are interpreted empirically because these kind of activities of seeking and finding lead to gestalts. For example, if one take Wittgenstein's example, if you trace a tree trunk in a puzzle picture, you see it as a tree. Similarly, if you use a physics theory to trace particles in a cloud chamber picture, you can see them as particles and so on. And Tuomas Tahko took this question of how to kind of use metaphysics as a meta theory for science. You just kind of have this kind of first develop a conceptual scheme, then use these models to construct paradigms and research programs and theories, and then test these theories empirically. So you end up with a worldview cycle or a pragmatic cycle in this sense. You have a worldview, then have interpretations, and then test them empirically. So this kind of worldview model for worldviews leads to kind of a debate model for worldview comparison. Marja-Liisa Kakkuri-Knuuttila developed a debate model for science. Also, Johann Georg Hamann argued that several languages can be in conflict or in mutual debate where they can reinterpret each other and also understand themselves better. And Alasdair MacIntyre developed a similar model for the comparison of incommensurable languages. A learns the language of B and vice versa. Then A can show that if B has no interpretative strategy for interpreting not so much theory but some phenomena, or then B is falsified metatheoretically because there's no strategy again in this Peirce's or Hintikka's sense, in a generalization in a way of that. Then Charles Taylor identified other grounds. If B can't recognize A success, or if A reorders the kind of interpretations of B, then obviously A's interpretative strategy comes out better, and you can give this kind of a sketch for debate rules. There are participants, for example, the worldviews of Descartes and Newton, or classical mechanics and quantum mechanics. Then is to assess, the goal of the debate is to assess these worldviews by kind of developing their interpretations and also their kind of moral values if we are talking about comprehensive worldviews or moral worldviews. Then the proponents of both worldviews learn the language of the other. For example, Descartes learns Newton's language and Newton Descartes, or the kind of classical theorist learns quantum language and the quantum physicians physicists, I'm sorry, not physicians, but physicists already know classical language out of their earlier training. Then both kind of worldviews assess the interpretations of each other and also their interpretative practices. And this kind of comparison highlights the strengths and weaknesses of these kind of interpretative links to kind of when one theory or worldview functions as a meta theory for the other. And this kind of, you can compare these kind of how well these kind of interpretations work. A worldview can offer a better response for kind of recognizing some orders and objects in reality, and also in the moral case of, say, for example, realizing some theory virtues, then the one which is better wins. And these kind of possible grounds are, for example, explaining more phenomena, showing that the interpretative practices of the competitors don't work, having a successful habit that the competitor can't recognize, and also removing problems and confusions. And there are these kind of possible outcomes. Either one wins, maybe there's a synthesis that kind of takes the best practices or best interpretations of both worldviews or frameworks into some kind of new frameworks, or maybe there's a modification of both of these theses or worldviews. So this kind of worldview comparison can be used to interpret scientific revolutions or conceptual changes in science, and also these kind of conceptual changes of science in science can also highlight how one worldview can be better than the other on kind of very kind of strong, or in the sense of scientific empirical grounds. I am using Heisenberg's description of the quantum revolution as a kind of starting point, and I'm just kind of going through his interpretations that it was a change in a worldview that had ontological significance. Physicists needed new theories to interpret new empirical phenomena, and these kind of conceptual presuppositions of these new theories led to ontological change. So there were these kind of anomalies for classical physics, the kind of spectra of black body radiation, light hitting metals, freeze electrons with certain amounts or packages of energy, why atoms have certain electron orbits. All of these are from the history of physics. And there's also the kind of question of wave and particle intertwining in the collision or collisions with X-rays, of particles with X-rays. And this kind of led into this kind of Heisenberg's matrix mechanics and Schrödinger's wave mechanics. So energy comes in packages. Matter has got wave-like and particle-like qualities. And then there's this correspondence principle that quantum theory can be a meta theory for classical physics by kind of when these kind of effects average each other out. And this kind of challenges the kind of classical ontological presuppositions, is these uncertainty principles, wave-particle dualism, kind of quantization, all kind of undermines certain metaphysical principles or rules of the classical way of thinking. So this kind of, and when we use this kind of comparison, debate model for comparison, then quantum mechanics can be seen as, again, in two senses, that it can first of all function as a meta theory for classical physics due to Bohr's principle, but it really kind of shows that classical physics has made this kind of conceptual commitments that lead to problems when, for example, both at the kind of ontological level and also at the empirical level, when kind of having to interpret this kind of the relationship of waves and particles and all kinds of uncertainties and also the quantization of this kind of physical phenomena. So quantum physics can show that classical physics simply doesn't have the kind of conceptual tools to understand these. So there's also the kind of 17th century scientific revolution. Here I am more kind of relying on the kind of interpretations of others. This kind of scientific revolution involved a shift from an Aristotelian worldview to a mechanist one. So, and there was this kind of comparison of two pragmatic circles of a conceptual scheme leading to paradigms, leading to theories and their empirical testings. They were compared through their empirical fruits. There's kind of medieval and Renaissance Aristotelianism was reinterpreted to Christianity. There were this kind of principles of the categories, the four causes, the idea that the world is somehow transparent or easily intelligible, and also this kind of knowledge had a theological aim. So this kind of, the problem with this kind of approach was that it didn't kind of mathematize nature, so it gave a poor foundation for physics. And Galilei and other early modern scientists took the atomist traditions and the mechanistic worldview as a foundation. It mathematized nature. It had these kind of principles of atomism, reductionism, and determinism, and also kind of using spatial and kinetic causes or mechanical interpretations. And it had the strength of supporting the mathematization of nature and physical science, but it leads to all of these kinds of traditional philosophical problems about reduction and so on, which are known from philosophy. And so these are kind of quick descriptions of these kind of worldviews or conceptual schemes. And there is kind of possible strengths and weaknesses. So they had this kind of, Aristotelianism had this kind of concepts of categories and causes, this kind of final causes as a kind of principle of interpretation, and also often had a theological kind of goal. Mechanism, on the other hand, had atoms and forces in absolute space, also had a mathematization and kind of mechanistic explanation in order to develop a theory of everything. So this kind of led to different scientific paradigms: geocentrism, natural place in Aristotelianism, and there's kind of also used hypothetical deductive explanations and also this kind of sphere model of this, and rising and falling bodies. And mechanical worldview then kind of had mathematical laws, the University of Matter. It used the method of resolution and composition, and also heliocentrism and simple machines as paradigm cases. So it led to a different kind of paradigm where this kind of mechanical laws, geometricization, mechanical hypothetical deduction, and also the solar system and simple machines as paradigm cases. So these kind of weaknesses of medieval and Renaissance Aristotelianism was revealed at the level of theories. This kind of question of falling objects, they had common language for measurements, and Galileo dropped cannonballs from the Tower of Pisa, and these kind of showed that they fell at the same rate. So there was a direct falsification. There was this kind of question of supralunar world, the telescopes show that it's not perfect. There's this kind of story that these kind of astronomers didn't look at the telescope, so they went, if this story is true, it's probably a myth, but if it had been true, then these kind of Aristotelians couldn't have recognized the strength of this kind of Galileo's theories and developed their own interpretations for the same phenomena. There's kind of dialectical problems also. This is from a second order source, I'm sorry, but this kind of, if this kind of geocentric interpretation collapses into a heliocentric one, then it is obviously in big problems. And also this kind of comparison of these kind of two pragmatic circles of a mechanistic metaphysics leading to Galilean or to Newtonian physics, to kind of testing heliocentrism and the dependence on fall on time, and the pragmatic circle of medieval Aristotelianism leading to Aristotelian physics, leading to testing natural motion and geocentrism through experiments and astronomical observations, also allows the empirical testings of these kind of metaphysical frameworks. And this kind of, in the case of physics, it turned out that mechanism was a lot better back then, and the strengths of Aristotelianism were elsewhere in its kind of holistic approach and strength in metaphysical description. Thank you.
Thank you for a very nice comparison. We have time for some questions.
Thank you for your talk. And my question is very fast. I was wondering whether you have considered the case in which you should suspend judgment on two worldviews.
You're talking about this kind of
Yeah, the point 5.
possible outcomes. A wins, B wins, synthesis, C, theses are modified. Actually, I'd say that if I was to answer this question, maybe I'd go back to Peirce and MacIntyre, who are my sources here. And MacIntyre says that everybody already has a worldview of some kind and uses it as a starting point to kind of go into dialogue with the others. So there's no possibility of radical skepticism. Also, Peirce makes pretty much the same point, that to have a doubt, it means that you don't have a habit or you don't have an interpretative strategy in the sense of having a belief or a whole belief system. So that's not really a live option.
And then we are unfortunately out of time again. Time for the next speaker. And let's thank Lauri once more.